Hello guys, in this video we are going to discuss the solution of the problem rotate and delete. So let us look at the problem statement. Problem statement says given an array ARR integers, do the following operation until a single element is left. For every kth operation, right rotate the vector clockwise by 1, delete the kth element from the last. Now find the element which is left at the last. So for instance, if this is the array which is given to us, if we rotate the element clockwise by 1 time and then delete the kth element, and if we keep on performing this operation till there exists just one element, then the last element which exists will be 3, and that is what we are going to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say this is the array which is given to us. So our objective is to rotate the array 1 time. So let us rotate the array clockwise in 1 time. So after rotation, the array will look something like this. And here the value of k is equals to 1. So we need to delete the last element. So let us delete the last element. Now again, let us rotate the array one more time. And here the value of k is equals to 2. So second last element has to be deleted. So this element will be deleted. And again, let us rotate the array. And here the value of k is equals to 3. So the third last element has to be deleted. So let us delete that. Now again, let us rotate the array. So this is the rotated array. Value of k is equals to 4. So we need to delete the fourth element. So which is the fourth element? So this is my first element, second, third, and then again this is our fourth element. So this element has to be deleted. Now again, let's rotate the array. So the rotated array will look something like this. The value of k is equals to 5. So the fifth element from last has to be deleted. So this is my first element, second element, then third, fourth, and fifth. So this element has to be deleted. So let us delete this element. And in this way, if we see, the element which remain over here is this element, and this is what we are going to return. And this is exactly what we are going to do in order to solve this problem. The only thing is there is one minor optimization which we have to do. So let us discuss that optimization. So here the optimization is essentially when k is equals to n by 2. So over here the value of n is 6. So 6 by 2. So k is equals to 3. So after the third deletion, which is this case, after the third deletion, we don't have to perform the other deletion. So these deletions we don't have to perform. After the third deletion, whatever is the 0th element, it will be our answer. So this is the 0th element and this will be our answer. So let us try to understand this with the help of another example. So let us say this is the array which is given to us. So this is our array. Now let us perform the same operation. So first what we want to do is we want to rotate this array. So let us rotate this array. So after rotation, the array will look something like this. And then the value of k is equals to 1. So we want to delete the last element. So let us say we have deleted the last element. After this, again we have to perform the rotation. So let us rotate this. So this is the rotated array. And here the value of k is equals to 2. So we want to delete the second last element. Again, let us rotate the array. Here the value of k is equals to 3. So the third last element will be deleted. Now again, let's rotate the array. Value of k is equals to 4. So the fourth element from the last will be deleted. So this is the fourth element and this will be deleted. And as you can see, the size of the array was equals to 8 and k is equals to n by 2. So 8 by 2, which is equals to 4. And this is our fourth deletion. So once we have deleted the fourth element, then the 0th position value will be our answer. So this will be our answer. Now let us verify this by performing all the deletion. So again, let us first rotate the array. So this is the rotated array and the value of k is equals to 5. So let us count 5 from the last. So this is 1, 2, 3, 4 and this is the fifth element. So let us delete this element. Again, let us rotate the array. Value of k is equals to 6. So let us count the sixth element. So 1, 2, 3, 4, 5 and 6. So this is the sixth element and this will be deleted. Again, let us rotate the array. So this is the rotated array and the value of k is equals to 7th. So let us count the 7th element. So this is my first element, second, third, fourth, fifth, 6th and 7th. So this is the 7th element and this will be deleted. Again, as you can see, after performing all the deletion, the element which remains is this element, and this is what we are going to delete. So this is the optimization which I was discussing about, which is when the value of k is equals to n by 2, and after performing the deletion, kth deletion, the 0th position element will be our answer. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to perform rotate and delete, and an array is given to us. So let us first compute the value of n, which is equals to length of array, and let's take I is equals to 1, and we are going to perform the deletion how many times? While I is less than n by 2 plus 1. Either you go with I is less than or equals to n by 2, or you can go with this condition, which is I is less than n by 2 plus 1. And then let us first rotate the array. So, and then the first thing which we are going to do is we are going to rotate the array. So let us discuss this case, how we can rotate it optimally. So let us say this is the array which is given to us, and since we have to rotate this array clockwise, so all we have to do is the last element has to be copied to the first element, and then all other elements have to be moved by one position. So this thing can be done in Python by arr.insert, and we want to insert at the 0th position. And which element we want to insert? Well, the element which we want to insert is the last element. So let us pop the last element and insert it at the 0th position. And after inserting, so once we have performed this operation, the resultant array, so once we have performed this operation, the resultant array will be something like this, and then we have to pop the ith element from the last. So the way we will be able to do it is essentially arr.pop minus ith element. So in this way, this last element will be popped. And then let us increase the value of I by 1. So I equals to I plus 1. And towards the end, the 0th element value will be our answer. So we just have to return arr of 0. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So n is equals to length of array, I equals to 1, and then we are iterating on I while I is less than n by 2 plus 1. And then first we are rotating the array, and after rotation we are popping the last element, and then increasing I by 1. And then towards the end we are returning arr 0. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ solution. So the C++ solution is also the same, folks. It is just that the implementation is a bit different, but logic wise it remains the same. So we have I and then the value of n. Then we are iterating on I while I is less than n by 2 plus 1. And then we are rotating the array. So in C++, to rotate a vector, a function is available, which is rotate function. To this function, we are passing 3 arguments. The first argument is the beginning of the array. The last argument is the end of the array. And the middle argument is essentially which element should become the first element. So since we want to rotate the array clockwise, because of which the last element should become the first element. That is why we are passing the index of last element. After rotating the array, we are deleting the ith element from last, which can be done by erase function. And then we are increasing the value of I by 1. And towards the end, we are returning arr 0. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. So that is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.